All right, so we have learned one trigonometric ratio fraction that allows us to find missing angles and missing sides in right triangles. And that was the tan of an angle. So let's refer to this diagram. The tan of angle A is equal to what side over what side? What are the names of the sides? Opposite over adjacent. In this diagram, what's the letter of the angle opposite angle capital A? Little a. What's the side adjacent to angle A? Little b. Or we could have called these, if we wanted to, BC and AC. Either one is fine. Okay? The only problem with this is sometimes we're going to be given information where we can't use tan. We're given different angles or sides. So we need two other trig ratios. And the two other trig ratios are the sine, which we just do SIN, of an angle. Well, that's a different ratio. It is equal to the opposite side, but not over the adjacent, over the hypotenuse side. So in our diagram up here, our right triangle, what's the side opposite angle A? Little a. What's the hypotenuse? Little c. So it's a different ratio. And again, I could have called that by capital letters BC over AB if I wanted to. Sometimes neither of these will work, so we need a third one to sort of cover all our bases. And that's something called the cosine, but we just abbreviated COS, or cos, of angle A. Well, this ratio is going to be the side adjacent to angle A over the length of the hypotenuse. So you see there are three different ratios. So going back to our diagram above, what side is adjacent to angle A? Little b. And the hypotenuse is little c. Or we could have done two capital letters for each, AC over AB. Every question you get, you'll be able to use one of these. Question is, how do we remember them? We usually use this. So, Toa. What does that mean? That means that the sine, if we're using it, is opposite over hypotenuse. C stands for cosine, and when we use cosine, we have to do adjacent over hypotenuse. T stands for tangent, or tan, which we learned at the beginning of this unit, opposite over adjacent. So if you can remember SOHCAHTOA. Let's have a look at some examples. And just like we started off with tan, we're going to start off with naming ratios. We're not going to find the angles yet. We're going to name the ratios or the fractions. So in this triangle called DEF, we want to identify the side opposite D and the side adjacent to D. What is the side length opposite angle D? 5 centimeters. What is the side adjacent to angle D? Careful with this one. 12 centimeters. 13 is the longest side, that's the hypotenuse. So to find the fractions for sine and cos of D, remember the sine, so is opposite over hypotenuse. What would that fraction or ratio look like? What numbers? 5 over 13. You all right? Okay. The cosine of angle D, well, Ka in SOHCAHTOA, so adjacent over hypotenuse, which would be what side length over what side length? 12 over 13. And that's it. We don't have to go any further in this question. The next step would be to actually find D. And just like we talked about with tangent, we can find angles if we're using sine and cosine by doing sine inverse or cosine inverse. So remember, set up an equation, get the unknown by itself, use your calculator. So we are asked to find angle G and H here. So let's start with G. And it says nearest 10, so that's 1 decimal place. So we know 2 sides. We're going to have to use these 2 sides, 6 and 14. If we're looking at angle G, what's the name of this side? Adjacent, opposite, or hypotenuse? It would be adjacent, because if we drew an arrow out, we did the opposite side. Well, we're not dealing with the opposite side in this question. We're not given any information about it. This is obviously the hypotenuse. This would be the adjacent, which means which trig are we going to use? Adjacent and hypotenuse. Cos. Yeah. So the cos of G is equal to 6 over 14. How do we get G by itself? How do we get rid of just cos? How do I cancel that out? Cos inverse. And whatever you do to one side of the equation, you have to do the exact same thing to the other. So to find G, we're going to do the cos inverse of 6 divided 14. And we're going to round it to 1 decimal place. $64.6 degrees is correct. right, let's find H. So now we're dealing with angle H. Forget about G. What's the name of this side in relation to H? Opposite. This is still hypotenuse, which means which trig are we going to use? Sine. So this time, the sine of angle H is going to be the opposite side 6. Oh, sorry, my mistake. No, not my mistake. That's right. And then to get H by itself, to get rid of sine, we sine inverse. And whatever you do to one side of the equation, you do to the other. If I was to do this in my head, I'm thinking I would get 25.4 degrees. How was I able to do that without using trig? Yes, we didn't have to use trig to find H. We could have just done 180 minus 90 minus G. Either way is fine. It's still going to get you the same answer. Using the trig is just fine. So we get 25.4 degrees. There's our two answers. Okay. The last example, I have to do a little drawing. A water bomber is flying at an altitude or height of 5,000 feet. The plane's radar shows that it is 8,000 feet from the target site. What is what's called the angle of elevation of the plane measured from the target site? Well, first of all, let's draw this. And we should be able to make a right triangle out of this situation. So I'm a pretty lousy drawer, so here's my plan. There's my water bomber. And here's the ground. And obviously the target site, where it wants to drop the water, is somewhere off in the distance. So somehow I have to make a right triangle out of this situation. Well, let's use this. How high is this off here? So we know that's 5,000 feet. And the height will always make a right angle with the ground, assuming that the ground is flat. So notice we've got two sides of a right triangle between the water bomber and the target side. Here, here, where do you think the third side would go to make the right triangle? Yeah, you slant it. There's your right triangle. And the plane's radar shows that it is 8,000 feet from the target site. Well, which one of these is 8,000 feet? The diagonal one? Okay. Now, we have to find one of the angles, and it's called the angle of elevation at the target site. Okay, when you stand and look at something, first of all, there's a horizontal. Okay, if you're standing straight and just looking out straight, here's my line of sight, right? Okay, as soon as I start to look up at something, there's an angle formed between my original horizontal and the line of sight, whatever I'm looking up to. That's called the angle of elevation. So the angle of elevation is always some person or some object is down here, and there's something else up here. And to find the angle of elevation from the lower object or person to the higher object or person, I draw an imaginary horizontal line. That's my starting angle, or my starting arm. And then there's another arm when I look straight up at the object or the person. This is called the angle of elevation. We call this imaginary line the horizontal. And this is our line of sight looking out. So if it's asking for the angle of elevation from the target site, it must be talking about this angle. Because the ground is the horizontal, and from the target site looking up to the plane is the line of sight. So that's our unknown. Okay? Now we have to find it. Think now, SOHCAHTOA. Don't be distracted. Stay on me. Okay? What trig ratio? I suppose you got a 1 in 3 chance. What's the name of this side? To the angle we're trying to find. What's the opposite? What's the same? What's the name of this side? So opposite hypotenuse is sine. So the sine of the angle, which is x, because I don't know, okay, is the opposite over hypotenuse. You don't have to write this part, understand, which in this case is 5,000 over 8,000. And now how do we get x by itself? Sine inverse. Sine inverse takes that out. Whatever you do to one side, you got to do to the other side. So to find x, I'm going to take the sine inverse of 5,000 over 8,000, and it says nearest degree, so that's nearest whole number, no decimals. 39 degrees. That's it. Okay. So really, there's only one more thing left to do, and that's how to find missing sides using sine and cos, which we'll talk about on Friday. So for Friday, you should have exercise 6.3 done.